And welcome back. In the last video, we discussed about the basic architecture of the 8279 and its various modes of operation. In this video, we're going to be understanding some of the jargon that we have used or will be using and the implication of the various modes of operation of the 8279. Let's look at some other jargon in understanding keyboards, because when you want to program the 8279, you need to understand these concepts. The first thing that you need to understand, the jargon that you need to understand, is something called a two-key lockout. Now, as the name lockout implies, it means that, so if you had a keyboard or a keyboard matrix connected to the 8279, there is a possibility that more than one key could get pressed by the user at the same time. But you as the programmer may choose to ignore such key presses, and the 8279 permits that. So you could program the 8279 to say, hey, always ensure that only one key is pressed, and if more than one key is pressed, ignore it. And the way it works is, look for a key, so the 8279 checks if a key has been pressed and then says, hey, has any other key been pressed too? If not, do I have space in the FIFO memory to store this key? And if I don't, the 8279 simply generates and sets the error flag so that the processor knows that the buffer is full. If the 8279 did have enough space, it would store the key code into this FIFO RAM. What happens if any other key was also pressed simultaneously? Very simple. Is it only one key after the two scans? So this is important. So you sense that a key has been pressed, and the 8279 immediately senses that more than one key has been pressed. So what the 8279 does is, it waits for two scan periods and checks again. And in those two scan periods, if the error has been resolved, it's very happy and it will read the input key that is now standing pressed. On the other hand, if more than one key continues to be pressed after the two scan periods, it just ignores the key press, nothing gets stored. It's as if the user did not press any key at all. This is called the two-key lockout. Now, in any computer keyboard, you know that there is a control and shift key. And in many, so you do a control C, you do a control V, you press a shift key to get the uppercase letters, so on and so forth. If you had a two-key lockout, none of this would work. So what you do is, the 8279 is intelligent enough to recognize whether a control or a shift key has been pressed in addition to any of the other keys. And if so, this operation is permitted. So two-key lockout ignores a key press only if more than one key is pressed, and if the second and third key, etc., are not the shift and control key. That's how you can manage multiple key presses in a standard keyboard. Let's move on to another version. In the N key rollover, this is called the N key rollover. The rollover is in contrast to the lockout. In this mode, very simple, any number of keys can be pressed, and the 8279 will happily recognize them. And it just keeps, so as it scans the keyboard, when it recognizes a key is pressed, it stores the key code into its FIFO RAM. Moves on, the next key code. Move on, the next key code. It continues to do this till the FIFO RAM is full. And the moment it becomes full, it starts generating it sets the error flag, and the processor knows that there has been a FIFO RAM buffer overflow. Obviously, you can generate an interrupt with every key code that gets sensed, and it is the processor's responsibility to constantly flush the FIFO RAM so that it never gets full. The last mode, and this is another special mode that the 8279 can operate in, is called the special error mode. And this can be done only under the previous condition of N key rollover. In this mode, if two keys are pressed simultaneously, the keys are ignored. Error flag is set, and no further keys are recognized till the processor resets the error flag. Interrupts continue to be generated. right? So if there are other key codes within the FIFO RAM, the interrupts for those key codes continue to be generated. The processor can continuously read those keys. But it is a responsibility of the programmer to ensure that he is constantly checking the error flag as well, just so that these kinds of conditions can be avoided. In case the error flag is set, the programmer has to reset the error flag so that additional new keys can be recognized by the 8279, a unique case under N-key rollover. What about the sensor matrix mode? This is the last mode under this scheme. In the sensor matrix mode, debounce is inhibited, so key debounce can happen, and the 8279 merely replicates the condition of the matrix, the keyboard matrix, into its FIFO RAM. You'll say, hey, this sounds crazy. Why would I ever use such a mode? Whenever a key is pressed, you want it to be recognized, but you want it to be recognized after debounce. And now you're telling me there's no debounce? What's wrong? There are situations where you do not want to debounce a switch. Now I'm not talking about the regular keyboard switch. It could be any switch. It could be a switch that you sense from a process control. It could be a switch, for example, in a car. It could be any other kind of switch where you don't need debounce. You just want to know how many times that switch has flashed. And this is a mode that the 8279 accommodates. And you could use this mode at your will. So you can keep switching the programs of the 8279 across any of these modes as you will, based on the needs of your software. Remember, ultimately the processor continues to hold responsibility for all actions of the system. Both the 8255 and the 8279 are mere slave devices to the 8086. Let's look at how to interface the 8279 to the 8086, and this is a small diagram that shows you how. So, of course, in this case, it's an I/O mapped situation. How do you know this? Because the I/O read and the I/O write signals from the 8086 are connected to the 8279. The interrupt of the processor is connected to the interrupt output of the 8279. So whenever a key is pressed, 8279 interrupts the 8086. This is the chip select decode. So the address lines A2 to A15 are used in this particular example to decode for the generating the appropriate chip select signal. This one outputs to the display device, 7-segment display hopefully, but output, these are pins that are connected to the display device. This is a scan line. Now the scan line has two functions. It has a function to enable display devices as well as to look for inputs from the keyboard device. So if you're in the display mode, the scan line is connected to the display. If you're in the keyboard mode, the scan line talks to the keyboard. And of course, the return lines are what comes as input into the 8279 from the keyboard. I told you about the shift and control being recognized separately. You will see two separate pins on the 8279. The shift key is connected to the shift pin. The control key is connected to the control pin. That's how even in the 2-key lockout mode, the shift and control keys are independently recognized by the 8279. In the case of a memory mapped system, so all the other functions, all the other keys are connected, all the other pins are connected in exactly the same way as in the I/O mapped case. The only difference is that the memory read and the memory write bar signals are connected to the 8279. This tells you that this is a memory mapped I/O, and you would use the move instruction, MOV instruction, to access the 8279 in this case. With that, I hope you got a flavor and a feel for how to use the 8279 in your designs. A lot of details are available in the fact sheets. I did not choose to go through them. There's just a set of facts that you may want to look at. It's available at Intel websites. It's available at any data sheet that you can see for the 8279. In our next video, what we're going to be discussing is how to interface a stepper motor to a processor. We'll talk about what a stepper motor is and how to use one in this context. Till then, please get more familiar with the 8255 and the 8279, extremely important slave peripheral devices that you must use with the 8086. Thank you very much. Happy reading.